Hello everyone, welcome you all to the session today, wherein we will be discussing a few more concepts from the topic percentage profit and loss, which is one of the important topics from point of view of your competitive exams. Arithmetic is important, and under arithmetic PPL is one of the most important topics. So today we'll look at few more concepts, right, from percentage only. We'll talk about profit and loss later, right. So in percentages, there is one important concept that we have, which is of the percentage change, right. So today we shall be talking about that specifically, right. For more detailed learning, right, I keep on telling this in all the other videos also. Please do get in touch with the closest center that you have, right, and check which course, all right, which batch would be suiting you, particularly if you're interested in doing your MBA. Okay. Let's get started. So percentage change. Now, what do we mean by percentage changes? Whenever the change from one value to the other is represented in terms of some relative fashion, like for example, maybe in terms of ratio or in terms of percentage, that change is easy to recall, easy to discuss also. For example, if I say the profit of a certain company in the year, let's say some year X, was 15,500 crores. Next year, in the year Y, X plus 1 rather, it became, right, let's say I write 18,600 crores. Now, it would be slightly difficult to remember these values as compared to saying the percentage increase here had been 20%. That means what? If it was 100 rupees or 100 units, the profit or sales here would be 120 rupees. That further means what? The ratio between the two will be 5:6. So these quantities are easy to remember as compared to the original values. That is why we go for calculation of percentage change always in our problems also, in our regular lives also. Right? With percentage change, thus is very important. Now, how do we calculate percentage change? If you have a variable whose value was X sometime in the past, its value is Y currently. So this is like the old value, previous value, this is the current value. Then in this case, the percentage change will be given as, alright. So when I say change, it could be an increase or decrease depending on the value is going up from X to Y or going down from X to Y. Percentage change will be given as difference between these two upon initial value. So always we divide by the initial value. So whatever comes first, that will come in the denominator into 100. So this is how you calculate the percentage change. So this is a very simple formula, but this concept of percentage change can be applied to a variety of problems, right? For example, let's look at few more things. There's one thing that we all know, I'm sure. So when you talk about percentage change in a variable with respect to other variable. So for example, if you note that there are two variables which are like X and Y whose ratio is constant. Always, ever, in the past also, in the present also, in the future also, always the ratio is constant. In this case, if you notice that the variable X is increasing by some A percentage. So how should Y change such that the ratio remains constant? Y will also increase by exactly the same percentage, isn't it? Think about it. If X increased by A percentage, it will become how much? X into 1 plus A by 100. Now, in order to keep the ratio constant, Y should also become Y into 1 plus A by 100, because eventually this cancels out. So for that to happen, Y should also grow by exactly A%. So when we are talking about ratio being constant, it's pretty easy to understand how would one variable change with respect to the other variable. Instead of increase, imagine if X decreases by some B percentage. In such a case, Y will also decrease by the same B percentage, exactly same B percentage. So in case of ratio, it's really easy to understand, right? How would one variable change with respect to change in the other variable? But if I take the following case, if product of two variables is constant, now what happens in such a case? So in such a case, if one of the variable changes, let's say this increases by some a percentage. So if one of the variable increase, the other shall decrease, because they are moving in opposite direction, their product should be constant. If one becomes bigger and bigger, the other should become smaller corresponding to that. So other will decrease, but will it decrease by a%? The answer is no, it won't decrease by a%. So then how much would it decrease by? Now this can be answered, right, very easily, very conveniently in fractional terms. So I am going to share a small trick at this point. So say for example, x increases by a certain percentage, which can be converted to a fraction. We have seen that in the previous video. So if x increases by a certain fraction such that it becomes p by q times x. So x is changing to p by q times. Now in order to keep the product constant, y should change as q by p times, isn't it? So that q and q, p and p cancels out, the product still is x into y, still constant. So if x changes as p by q times, y should change as q by p times, right? So for example, if I take some numerical values, if x increases by 25%, let's say, so if x is increasing by 25%, means it will increase by 1/4. And if it increases by 1/4, it means it will become 5 by 4th x. And if x becomes 5 by 4th, y should corresponding to that should become 4 by 5. Correct? So if y is becoming 4/5, please understand what does it mean? Y is decreasing from y, now it's becoming 4/5. How much is it decreasing by? Can I say it's decreasing by 1/5? So it's decreasing by 1/5 y. So if x increases in this fashion, it will become this. So corresponding to that, y should become this, which in turn means y will decrease by 1/5. Okay. So there's a small trick that we can try to learn here. So I'll just try to write down the trick here, that you may remember in all your problems where product of variables is constant. So whenever product of two variables is constant and you notice that one of the two variable is increasing, so immediately you can conclude the other should decrease. If it is increasing by a fraction p by qth, say 3 by 4, 4 by 5, 2 by 3, any fraction, it's increasing by some percentage or fraction, then the other variable shall decrease by p upon q plus pth. Now you can just try to apply that here. Please notice, this was p by q, p was 1, q was 4. So if this one variable increased by p by q, the other is decreasing by how much? P by q plus p, 1 by 4 plus 1. So that's what I'm writing there. P upon q plus pth would be the decrease in the other variable, right? Similarly, if one of the two variable decreases up by a by bth, some other fraction, right, then the other should increase, and it will increase by a upon b minus ath. So these are the rules, the techniques, the tricks that we have with respect to percentage changes that we should be aware of. This is one thing. Besides this, there is something else called as successive percentage change. So what do we mean by successive percentage changes? As the term itself indicates, successive means one after the other. So for example, let's say there is a variable x, it first increases by m percentage, then it increases by n percentage, and finally it becomes y. What is the overall change from x to y? So what is the overall percentage change given as? So it will be given as the formula, directly I am writing it, no need to prove it. Sum of the two, m plus n, plus m into n by 100 percentage. Okay. So overall the successive percentage growth, alright, or the cumulative growth will be given like this: m plus n plus m into n by 100, sum plus product by 100 percentage. Now how does this come? If you want to understand that, please notice one small numerical example. Say the variable increased by 20%, following that it increased by 10%. So what is the overall increase? I am not going by the formula here. So the overall increase can be understood to be as, observe, whatever variable you would have taken, x, firstly it would have grown by 20%, correct? So 20% will be there. So if it grows by 20%, it will become how much? X plus 20% of x, correct? Here. So it would have grown by 20%, I write that. Now further, this entire value will grow by 10%. So please understand, this 10% is applied on what? This 10% is applied on this x, so there will be a growth of 10% of x, plus this 10% again is applied on this 20% also, please notice, right, on this 20 also. So that means overall what is the value? 20 plus 10 plus 10 into 20, or rather 20 into 10 by 100. So that is why m plus n plus m into n by 100 is the formula that we get. And there's a logic behind the formula. No need to go for the logic every time, right? No need to do it like that every time. We can simply apply the formula. Now let's look at some of the questions. So for example, look at this question. You can pause it for a minute, try it out. I'll discuss it anyways here. Price of tea increased by 56.25% in the year 24 as compared to 23. Okay, so the price is increasing. If the family wanted to keep the expenditure of the tea at the same level as in 23, so in 24 also they want to keep the same expenditure, and we know that expenditure is nothing but price into consumption, right, of tea. I want to keep the expenditure constant. So that means the product of these two variables is constant. And then he says one of the variable increases by how much? 56.25%. What should happen to the consumption? It should decrease. He is asking us what should be the percentage change in consumption of tea. So we know one thing, that if this increases, this should decrease. Now one more important thing that we need to understand is, what is this 56.25% in fractional terms? Can we write it as 50 plus 6.25%? 50% is half, 6.25% will be 1 by 16. So when you add it by taking LCM, you will get as 9 by 16. So that means this variable price is increasing by 9 by 16th. So if this increases by P by Q, the other will decrease by P by Q plus Pth. So it will decrease by P by Q plus Pth. So that means it will decrease by, that is consumption will decrease by 9 by 25th. And since we want our answer in percentage, can we simply not multiply this by 100? Since we want it in percentage, 25 goes 4 times. So 9 into 4, it will go down by 36%. So thus the answer for this question should be 36%. And the answer is obtained in relatively simpler approach by taking up the trick that we have discussed. I hope we are clear with this. Moving on. Okay, so next one. So it's more like a DI set, but we are trying to learn the percentage application of it. So look at the DI. Please look at it once. Right. So it says the following pie charts give details of the sales volume of the company which sells 5 products A, B, C, D, E. So we are given with sales volume in the year 23 and also in 24. The breakup is given, right. So as we can see, there are 5 products in each of the year, right. So A is 20% here. This is B, this is C, this is D, this is E. Likewise, A to E are marked there. The colors are marked. Now the question based on this is, what is the percentage increase in sales of product A? So A from here to there, right, from 23 to 24, if the ratio of the sales volume in 23 and 24 is 4:7. Means what? If I take the value here as 400, so this should be 700, right? So if I take this as 400, total value, that should be 700. So A will be how much? 20% of 400 means 80. Here A is 80, right? Here it will be how much? 28% of 700. So it's 7 into 28, which will be 196. So A is going to be 196. So from 80, if the value has to become 196, what is the percentage increase? So 80 has to become 196. So what is the percentage increase? The increase will be 116, right? Upon 80 into 100. So when you solve this, 20 goes 4 times, 20 goes 5 times, 4 goes 29 times. So 29 into 5 is 145%. So this is going to be our answer for this. But just imagine, had the percentages been, instead of 20 and 28, had the percentages been something like, observe, 16.2% here, okay, 16.2% here, and let's assume here they had been 21.6%. So I'm changing the percentages slightly to discuss a particular concept. So 16.2, 21.6. Now in this particular case, please notice, calculations of this kind will not be so easy. As we did here, 20% of 400, very easy, but 16.2% of 400 will take some more time. 21.6% of 700 will take some more time as compared to 28%. Now what can we do in such case is, please, you note this down first. We'll discuss alternate approach for this. So if you look at the alternate approach, that is to do with successive percentage change here. So even in your pie charts based questions, data interpretation sets, we may apply the concepts of your percentages as follows. Here, what is the value of sector A? Sector A is nothing but 20% of the total value in 2023, right? Whatever the value in 2023 is, 20% of that is your value of sector A. What is the value of sector A here? Similarly, 28% of 2024. So that means if you notice, the value of the sector A is determined by two parameters. What are the parameters? Percentage is one, the year total value is the other. Percentage and the total value, right? Now, whenever you come across a case where a particular variable is made up of product of two different variables, like this into this into this, you can break down the problem into two parts. If there are two parameters affecting your answer, what you may do is, you can just check how is the percentage value changing. So it's becoming 20 to 28. So 20 to 28 means what? So there's an increase of 8 on 20, right? 20 to 28, the value is increasing by 8 units on 20. What is the percentage increase here? It will be 40%, right? 5 times 40%. So that means one of the parameters is growing from this year to the other year by 40%. Now what is happening to the other parameter? Now if you look at the other parameter, which is 2023 to 2024, what is happening to this? So if you look at the other parameter, it's given to be in the ratio 4:7. That means if this was 4 units, this will be 7 units. So what's the percentage rise here in the other parameter? 4 to 7, there is an increase of 3 on a base of 4, which in percentage is nothing but 75%. One of the parameter grows by 40, other parameter grows by 75. In such a case, overall variable will grow by successive percentage of these two because the variables are multiplied. So the rule is in mathematics, right, or in DI also, whenever you notice that the variables are getting multiplied, you can always apply successive percentage change over there. So 40 and 75 will give you what overall? 40 plus 75 plus 40 into 75 by 100. So it's 115 plus this will give us what? 25 3 times, 25 4 times, 4 10 times, 30. So it's going to give us still the same answer that we got previously, 145%. Previously also we got the same answer. Here by using successive percentage change also we'll get the same answer. Now the major advantage here is, please note it down, I'll tell you the major advantage. The major advantage here is, imagine, had this value, instead of being 20 and 28, had it been, what did I say, 16.2 and 21.6. Even then there is no actual need of performing these calculations. Even then you may say this variable is changing by how much? So 16.2 is becoming 21.6. So 5.4 increase on 16.2 is 1 by 3, and 1 by 3 in percentage is 33.33%. So one parameter is growing by 33%, the other is still growing by 75%. So what is going to be our answer? Sum of these two plus product of these two, 33.33 by 100. 33.33 by 100 is 1 by 3 approximately, and 1 by 3, 25. So it's going to be 133.33% will be the answer. So even in that case, if the percentages are changed slightly into a more complicated values, we can still get our answer in almost similar kind of difficulty. So it's not going to increase a lot, right, the difficulty and all. So basic point here is successive percentage change can be used in all the problems where the variables are getting multiplied, like in this case. I hope we are clear with this. Okay, so with that, we have come to the end of the session here, right. I hope you followed it, alright, but for more such content, please ensure that you subscribe this channel. Thank you and all the very best.